Okay, so welcome back to my new video. In this tutorial, I'm going to teach you how you can use the Kubernetes Services object to exposing your apps to the entire world. Okay, so by default, every pod will be assigned an ephemeral cluster internal IP address, meaning that once you create your pod, Kubernetes automatically assigns an IP address to this pod. That is for internal communication purposes. But there are cases also where your pod may die or they may restart and things like that. And once they die and they come back to life, they might be assigned, they'll be assigned a new IP address, I would say. So in doing so, we need a way to solve such a problem where pods assign new IP addresses each time they restart or each time they die and come back to life. So if you have a set of pod replicas or deployment, how to create a stable endpoint? What do you do to create a stable endpoint to solve such a problem? That is where services abstraction is designed to expose an app as a service. So you can think about microservices. And then also services are created to load balance traffic or routing traffic to healthy or unavailable ports, I would say. And then also with services, you use labels and selectors to select the right deployment or port to attach services to. Okay, so once a pod dies and comes back to life, they're able to use those labels and selectors to attach themselves to the service. Okay, so here we have a prod service, and this prod service has a cluster IP, a stable network endpoint, and is able to load balance traffic to prod deployment ports. So as you can see in the diagram, we have two nodes, and then the node one has 3 deployments, and 2 of them is tagged as prod, and 1 of them is dev. And then the second node has 2 deployments, and each one is tagged as prod and dev. So you can see that the prod service is attaching itself to those deployments tagged as prod only, leaving the dev deployments alone, because the service, according to the definition, it should only attach itself to prod deployments only. So there are types of services. The first one is ClusterIP. They expose the service on a cluster internal IP. And then the NodePort is to expose the service on each of the nodes IP at a static port. So that's why you call it NodePort in code. And then the load balancer creates an external load balancer which routes traffic or requests to NodePort and ClusterIP services. And the last one is the Ingress controllers. Mostly, you might see this very often with managed Kubernetes services. So the NodePort service. So once you are outside the cluster, the Kubernetes cluster, and you are sending a request from the internet into the Kubernetes clusters, the request goes or hits the NodePort, and then the NodePort will forward the request to the prod service, and the prod service is inside the clusters, and the prod service will then forward the request to the right deployment based on the labels and selectors tags. Okay, so as you can see, we have 2 nodes, and this prod service is forwarding the request to the right deployment. Okay, so the load balancer service is again the same, but there's another layer introduced, which is the load balancer layer. So once you are outside the Kubernetes clusters, you send a request. The request is going to hit the load balancer first. That comes with the external IP address. And this external IP address will then forward the request to the NodePort service. And then the NodePort will then forward the request to the prod service. And then the service will then forward the request to the right or the appropriate deployment based on the tags. So that is load balancer. Yeah, so I think that is it. I'm going to switch back to the terminal so we can work on some examples. So I'm now in my terminal. So I'm going to check my Kubernetes clusters, kubectl get node. Okay, so I have two nodes from AKS, that's Azure Kubernetes Services, running. And I'm going to create two YAML files. The first YAML file is the deployment, and then the second one is the service. Okay, so that the service is going to help us expose our deployment to the outside world. So I'm going to say kubectl create deployment. And this deployment, we are going to call it Nginx app. And then the image we are going to use is Nginx 1.14.2. And then the port is 80. And then we use the dry run parameter, meaning that we want to direct the output to the YAML, but we don't want to run it inside the cluster yet. We just want to forward the output to nginx.yaml. I'm going to run that. So it's created, as you can see, nginx.yaml. And then I'm going to create the service as well, kubectl expose. So I'm going to expose this deployment Nginx app on port 80, and then the target port is 80, and the type of service I'm trying to create is load balancer, and then the name of this service is Nginx service, and then the dry run is output to YAML, and then we redirect the output to service.yaml. So I'm going to run that as well. Okay, it says Nginx app not found. Okay, so let me create the Nginx first. So I'm going to say kubectl apply. And then we are already in the default namespace, so I don't actually need that. So when we say kubectl get ports, so you can see it's currently running. So I'm now going to expose or create a service.yaml file. So if I do that, so as you can see, we've just created a service.yaml. We can have a look. When I say cat service.yaml. So this is the service YAML file or the service object. And the name is what? Nginx service. And then the app is what? Nginx app. And then the port is 80. Protocol is TCP, and the target port is 80. And then the type of service we are looking at is load balancer. This time we are not using the NodePort or anything. So I'm going to create this as well. I'm going to say kubectl apply. And then we are going to look at we're going to say kubectl apply -f service.yaml. Okay, so I'm going to run that as well. See service created. So we can do kubectl get all. So as you can see, we have the pod running, and then the service is what? Nginx service, and the type is load balancer. You see the cluster IP, and then the external IP is pending. So let's wait for it, the service. kubectl get service output wide, and then we want to watch. Okay, so it's done. And then this is the external IP that we can use. So I'm going to copy that. So you see the node port, this is the node port 30997. And then the target port is 80. Okay, so let's see if we can curl this endpoint. The endpoint is 20.92.137.186. So if we curl this endpoint, you see we have this result back. It says what? Thank you for using Nginx, or welcome to Nginx. So I'm going to the browser, and then we can check the output also from the browser. You see, so as you can see, this is my Kubernetes cluster that I'm running. So let me open a new tab and then just paste the IP address in there. So as you can see, welcome to Nginx. Welcome to Nginx. So what we can also do is, so basically this is working. We can share this IP address with anybody, and they'll be able to access this endpoint. Let me go back to the terminal. So currently I'm in the terminal. So what we can also do is kubectl get port. So this is, we have only one pod running. So I'm going to scale it. kubectl scale deployment Nginx app. And then we want to scale it to, let's say 5 pods. You see, container creating. Let's watch. I think it should be done by now. So as you can see, we have 5 of the pods running. We can also do horizontal auto scale. Whenever the CPU utilization increases beyond certain threshold, we want to scale our application. So with Kubernetes, it's called HPA, kubectl get HPA, horizontal pod auto scaling. We don't have anything running. So we can also say kubectl auto scale. The name of our deployment is Nginx app -app. And then the minimum pod we'll be looking at is 2, and then the maximum is 10 or 20, whatever you choose, or minimum as what, 3. And then if the CPU utilization percent is 80 or more, we want to scale the the Nginx app between 3 to 20. So if I run this, it's created. So if I go up and say get HPA, you can see the HPA is created 4 seconds ago with minimum port of 3 and then maximum port of 20. Okay, so let me try this out. I haven't tried this. Dry run is equal to client output YAML, and then we redirect to HPA.YAML. Okay, so it's created. It's created. So if I cut HPA, see, so we can create it as a YAML file with this configuration. You see, target CPU utilization percentage is 80. That is what we have set. And then the minimum and then the maximum is 20. So I can say kubectl delete HPA. Then the name of the HPA is Nginx-app. So it's deleted. So now I can run it using the apply command -F HPA. I made a mistake. kubectl apply -F HPA.YAML. So again, it's created. We can check it, get HPA. It's created 7 seconds ago. So that is what you can do with services, and then HPA, which is horizontal port auto scaling. I thank you for watching this video. If you like it, please subscribe and like the video and share. And I'll see you in the next one. Thanks for watching.